So let's talk about the QUIC protocol. There's an interesting fact about it. Before referring to the name QUIC, it was originally called as GQuick, and then it began changing its name and removed the G, and now it's called QUIC. So it was actually introduced in 2012, and it was affiliated by the IETF in the year about 2016, and they sent the request in the year 2015, so it took 1 year. And QUIC is nothing but another protocol on the transportation layer. It was designed by the Google in the 2012, which I talked about. It uses the original protocol called UDP and stacked upon it. And the other, it is highly encrypted protocol, and it uses the protocol called TLS version 1.3, and it is helping to do the multiplexing, which actually is also the part of the HTTP protocol 2, but QUIC uses HTTP protocol 3. So when QUIC was designed, HTTP protocol number 3 was also designed. So now I talked about uh, being QUIC being stacked upon the UDP. So UDP is much more simpler. It just requires a destination port and a source port. And talking about the TCP protocol, it requires a three-way handshake. So we have we have a network layer which stands with the IP protocol. It has an IP protocol. We have a transport layer which has a TCP protocol, and then we need to encrypt our data. The HTTP version 2 needs to encrypt its data, so we are using the TLS protocol. In talking about in case of QUIC, we have UDP, then QUIC is stacked upon it, and a built-in encryption is done with the help of TLS. So QUIC basically deals with too much of encryption, so it is highly protected. And when QUIC was designed, they wanted something new, so the HTTP 3 was designed. Now the difference between the HTTP 2 and 3 is something like 2 deals with the priority, and it wasn't much visible, so they designed something called HTTP protocol 3, and which doesn't deal with the priority. Now, why was there a need for QUIC? Now, talking about the TCP, it has three-way handshake, so it is highly, the latency seems to be at its peak because something, the connection breaks or something, so the latency part of it, QUIC reduces that latency. Now, if you're looking at the first connection by the QUIC and in comparing it with the TCP protocol, so the TCP in here would be like the SYN, then SYN, then we have ACK, then the GET request, the HTTP. So if you're looking at this QUIC right now, you would be like, it's similar. Like it initializes the hello, it gets the response back, and then the HTTP, and the getting back the response from the server, the 200 in OK. You will be like, it's similar to that. But here's the catch. If you make the another request, the subsequent request, the TCP protocol still has to give the sync act request again, and then you give the get request and get the response back. But in case of QUIC, it's just 1 RT, or sometimes it's 0 RT. It gets you the response immediately. So you initialize the request, initialize the hello, and the get request simultaneously. And TCP keeps on has to do the three-way handshake whenever it is requesting for something. So it reduced the latency. Now multiplexing. So HTTP2 reduced the multiplexing, but it still uses the protocol called TCP. So it is a pipeline. So something gets lost somewhere, it has to, even though other packets have reached the client, but something is missing. So it won't be sending or decrypting the packets which are behind it, even though they are at the client side. So that is in the case in QUIC. QUIC just holds a particular packet which isn't completely transferred to the client side of it. And it is done with the help of streams. So in TCP we have a pipeline, and in QUIC we have multiple streams going across. Now, the better congestion control provides the enhanced congestion control, just like we are moving on to a different network condition. The connection doesn't change. You are particularly assigned with the destination connection ID. It doesn't change. It has all those information. So if you are moving on to the next server or connecting onto the next network, it still have all those things that it needs to. So the zero RTT. And comparing this QUIC versus the TCP, TLS, and HTTP2. So TCP, it uses a protocol called TCP. QUIC uses UDP encryption. There is a separate layer, and in case of QUIC, we saw there was a built-in layer inside that QUIC. Earlier, there was the cryptographic layer. Now it uses the TLS when it was actually affiliated. Then the multiplexing, so head of line blocking. So I talked about if the pipeline there's something goes missing, it holds the other things back. But it doesn't happen in case of QUIC because there are multiple streams going across. Then the connection established multiple round trips, three-way handshake that we discussed. In case of QUIC, it's zero RT. Now, in talking about the packet loss, TCP is very well in transmission, but in case of QUIC, we have called stream transmission. So, particular stream sends the request for that particular packet instead of sending the request for the entire packet. Now, looking at the frame formats, we have TCP, which requires source port, destination port, sequence number, acknowledgement number, header length, flags, windows, checksum, urgent pointer, types, version, length, and we have this payload of the application layer, so earlier layer. Now, moving to the right side, if you look onto it, we have some areas gray and black. So black, you can't make any changes and you can't even see anything. So if you can't see anything, you won't be able to make any changes. And talking about the gray area, you can see it, but you can't make any changes. And the white area, you can make changes. And in moving on to the QUIC, we have the source port, destination port. It is the part of UDP because it's stacked upon it. Then we have length, checksum, and these are the 01S RRK double P is nothing but the flag. So 0, the first bit stands, so whenever it's 0, it means the short header. If it's 1, it means long header. Then moving on to the second bit, which is 1, it's a fixed bit, so it will always be 1. Then we have S, which is for the sync, it's for the latency part of it. Then RR, which stands for the reserved bits, and K is stands for the key phase. So it tells you what kind of methods you are going to be using for the encryption part. Then we have P double P, and which stands for the packet number. Then the destination ID. So destination ID is must, and the packet number, and what kind of data we were getting from the application there. Now, looking at what kind of encryption it does, it actually hides the reserve ID keys, what kind of, and all those things inside the packet. So, what is the size of the packet, and what was the size, whatever the information was of the payload from the previous application layer, basically. And the destination ID is gray. You can see it, but you can't modify it. Source word are all those things that could be modified. Now advantages, it's faster connection, zero RTT, improved congestion control. We talked about it like multiple streams, better performance in high latency networks, multiplexing without the head of line, which is the power of TCP. It still deals with that. Then the disadvantages, sometimes UDP is not very well with the firewalls. So, and for example, taking an example of NAT, it doesn't deal well with it. And it's complex because it is actually working on the user space instead of the kernel space. Now the application of QUIC, we particular have Google services which uses Chrome. YouTube is one of the major which uses QUIC. We have Gmail, and talking about the content delivery networks like Cloudflare and all those things. And HTTP was the one designed for the QUIC. So then the security aspect, potential security threat could be the affiliation attacks. So whenever there is a handshake, the destination connection ID is shown to us. So there could be malicious activity going on there if somebody knows how to do it. Then man in the middle is eliminated in this because there is end-to-end encryption. Then we have traffic analysis. We can't do any traffic analysis because we can't see much of the information in the QUIC. Now the mitigation technique using the rate limiting to prevent the affiliation for the affiliation attacks. Then the firewalls rules could be there for the QUIC. So I was talking about the stream part of it. I wanted you to visualize it. So in case of TCP connection, it is going through a pipeline. So something goes missing, the other packets able uh, won't be able to provide something to the client. And the TCP has all those streams. So if something goes missing, only that particular thing would be the one dealing with the. It could be the retransmission. So only the request for the particular packet will be sent to the server to get back the packet. So let's learn how to see the QUIC protocol on the Wireshark individually. And before diving on to the QUIC protocol, I would like to say there are multiple applications that actually runs on the QUIC, but I'll be talking about the YouTube one because when it started, was the one who was prominent with, which application which used the QUIC protocol back in the days. And before that, even looking at the QUIC, we need to know that the encryption of the QUIC happens with the help of the protocol called TLS, version 1.3. And it is the one who actually, from the client sends the hello, then the server sends the hello, and the cipher suit is the one which actually helps to encrypt the data, which is unencrypted. And after that, all those encrypted data is sent in form of the application data. So all those sort of things, I have already looked onto the YouTube website and it has given me something like this. So the TLS version 1.3 actually sends the client hello and the server acknowledges it. So how do I know the server acknowledges it? Because the server sends a hello part. And after that, I talked about the cipher suit actually encrypting the data. So here it encrypts the data and after that it sends the application data. Now let's search for the QUIC and how it actually deals. So QUIC actually is a stack upon the UDP protocol, and UDP protocol is much more simpler comparing to the TCP because TCP requires a three-way handshake. UDP protocol just requires a destination IP address and a source IP address, and same goes for the QUIC. QUIC just requires a destination connection ID and a source connection ID. So it's asking for the destination connection ID. Now it uses the crypto frame. There are multiple frames, crypto frames, pings, and all those sorts of things. And we just require I talked about it, just require the destination connection ID and a source connection ID and the packet number. So all those particular streams running across the QUIC protocol has a particular number. So that's a packet number. So this is how you search for the QUIC onto the Wireshark. So thanks for watching the video.